Okay, in this video, we're going to start coding the spawner. And rather than you guys watch me type and mistype and debug, we're just going to walk through the code at a slow pace and have it up on screen so you can see it clearly and crisply, um, and code the basics of the spawner. Right. So what we're really focusing in on from our last video is we're gonna focus on setting up the foundation, which is when and how to activate and deactivate the AIs. We're really not going to cover these pieces yet. We're really just focusing on getting a functioning spawner. And so let's jump into the code and take a look at that. And then we'll jump into the editor and see how it plays out in the editor. Okay, so it's time to kind of go through the basic spawner code. This will set the foundation and we'll continue to enhance this and grow from here. But what we're going to do is walk through the code slowly. That'll give you an idea of understanding it and being able to recreate it if this suits your purpose, or at least learn from it. So I've opened up the header file and the C++, and I've spent a couple of hours writing this, debugging it, and getting it to work. So let's start kind of at the top. There's nothing really to include in the spawner. We just have our standard includes here. We've created a new log category. So we have the log AI spawner as a new log category. So this creates a way for us to turn logging on and off. Then the first thing we did is said we built an enum, and this is how you define an enum in C++ if you typically work in Blueprint. But we've got three states just to start with, right? We have a stationary, a moving, and interactable. So that would be a stationary AI that's just kind of standing there in the background. Moving would be someone that has to have some movement. So we'll have a sort of a pathing system that they'll be able to move along. Interactable will enable some interaction with the character so that the player can interact with that character. So those are the three we just started with. We'll expand that list into a variety of more types of AIs. But to start with, we created that enum. And then we need this structure. And this structure is basically the data structure for setting up any given spawner. First, we need a subclass of the AI pawn. So the AI pawn that we talked about and decided on in the last video, we create this struct and expose. So note that this one and this one have a U property. That means they're going to be exposed in the blueprint so that the designers of the level can interact with those two. There are four other variables here that are not being exposed through Blueprint. So the structure can contain both variables that you want a designer to be able to modify, as well as variables that are internal to the workings of your class, and you don't need anyone to see those. And so this is sort of how you define it now. You have to define the struct blueprint type here and the enum blueprint type here if you want to use these in Blueprint. If you were just doing C++, you wouldn't need those, but making them available through Blueprint, then making this property available and this property available. So the class we're going to spawn, the AI type that it's going to be, and we're going to default that to stationary. These we're going to use in our code, these four variables. So that's the enum and the struct. This is probably something not a lot of people do, but I find it's useful for classes where you're going to have lots of copies of it and maybe multiple people editing it. In your U class, you can use this hide categories, and you can hide any number of the categories that are enabled by default from the children of this class. And so I've gone ahead and hidden all of them except the one I want to show, which is called setup. So all of the transform, physics, collision, lighting, all of those are going to be hidden in the blueprint when we get there. actor tick is in quotes because there's a space in that particular one, but otherwise you can just type the name or Google to look up what they are. Or in cases where there's a space, you put a space in there. All right, so then this is our main spawner class. The way I've set it up is I have the variables first and then the functions second. You can intermix them in your classes. It's just organizational structure of your choosing. I've added two components, but I have not exposed them to Blueprint. So these two components do not have U properties on them because I really don't want anyone in the editor to have to deal with it. The important one is this sphere, which is going to be what triggers our spawning and despawning. So that circle we had around our AIs is going to be represented by this sphere component trigger radius. Then I have some variables, and I've set them up under the category of setup. The first being a float, which is what is the radius, so that we can change the radius of the AI spawners in the world to make different senses. This one's more for debugging, whether or not we want to show the radius in the game. We default to off. This is the array of the struct from above. So this is the struct we created at the top. And this is an array so that I can have multiple AIs being spawned off of one spawner. So this is the kind of the workhorse element of this class. And then I have a frequency that every 2 minutes, I want the spawner to wake up and see if there's anybody around it. The reason, you're going to see a little later, the reason we set this up this way is for the scenario where the player might be inside an AI spawner and then log out or exit. They never actually left the area, like via an event trigger. So every 2 minutes, we're waking up and saying, hey, is there anyone in my space when I'm active? So that's what that variable is for. I just started putting these in here. We're not going to use them. There's nothing in this video regarding them right now, but these will be for when we respawn trash mobs when people die. Then I have my internal variables here. So instead of using tick, we're going to be using some event timers. And so for event timers, you need these handles. So we have a respawn timer handle, and then check for players nearby timer handle. So the respawn is for the respawn. The check for nearby players is the one that wakes up every 2 minutes, unless we change it, and checks for players. I've got two latches. One is to prevent duplicative spawning of AIs, and one to prevent from duplicative despawning of AIs or disabling of AIs. And then I have a variable to count how many active pawns are still alive and in the game. And this again is more for the trash mob scenario where we want to count down the number of AIs that are alive and then set the timer to do that. So this isn't being used, and these respawns are not being used yet, but they will. All right, then let's take a look at our functions. So for the functions, always good to edit while working. The first thing we did is we used this post init properties, and this function is part of the actor class, and it triggers when all of the properties from your blueprint have been applied to the class. And so it's a useful routine to run logic that needs access to the properties that are in your blueprint class, but before begin play. So sometimes you do this stuff on begin play. In the case where we want things to happen in the editor without begin play, we'll use this routine. Then we have our constructor. We have our begin play. We have two overlap begin and overlap end. And these signatures, you can just Google what what these signatures need to look like. So I didn't come up with that. Those are copied. But basically, there's the begin. And let's just break it right here, which looks like that. And then the end. So you have to make these U functions because we're going to dynamically bind to these two functions in our C++ code. So we have the two U functions on overlap begin and end. This signature has to match just like these two. And then we should be good to go. We have enable pawns and disable pawns as the two primary functions that we're going to be triggering when the conditions are correct, and then our check for players nearby. So those are our basic functions. The other one we have down here is for in-editor editing. So we're using the post-edit change property. This event is only valid in the editor. So you'll note that I have it wrapped with if with editor. And if you didn't wrap it with that, when you tried to build this for a shipment, build a executable, it would fail. It wouldn't compile. So we need to wrap that with the if with editor. And this is, again, another function that we're overriding from a parent. Right? So that's an override from a parent. And that's it. Those are all the functions. I'll leave it on screen a few seconds longer. And let's go look at the C++ for this, and we'll do that sort of line by line. All right, over in the C++, we have our spawner and our AI, our sphere, and we needed to add the Lyra character. So those are the 4 includes that are necessary. Here we define the logging category that we declared in the header file. So this allows us to use the log AI spawner. Here's our constructor. And so the first thing we're doing is we're saying don't tick. This actor does not need to tick. We're going to be handling all of our iterations through event timers because it's more performant. We don't need to load on the clients. So this B net load on client false means that when the map loads, it will only load these actors on the server, which was part of our design. We created a default uScene object. This is so that we could scale and resize things independent rather than just having the sphere. And then we have the sphere. So the scene component is the root, which we set right here. And then the trigger radius, which is the sphere component, is attached to the root here. And we set its collision profile to trigger. And you might be wondering, okay, where does that come from? You know, that may not be something you normally see. So let me pull up. What I'm going to do is go into folder, this project. I'm going into config and then default engine INI. And I'll pull that up over here. So in default engine INI, you have a bunch of settings. And if you scroll down, you will see this collision profile section. So this is the engine collision profiles. And each of these profiles has a name. So this profile is no collision. And then it has all of these things, the object type, the response channels. This one has block all, overlap all dynamic, ignore only pawns, overlap only pawns, spectator, character mesh, etc., etc., etc. And then there's this one called trigger. And so trigger is a profile in the default engine INI that sets the object query and all of the channel responses to a fixed sort of set of settings. And there's more, there's ragdoll, and there's some Lyra ones down at the bottom. But basically, these profiles are an easy way to set up a set of overlap criteria once and then use it with a simple word. So that's, I didn't add that, by the way. That's already in your default engine INI. I am simply referring to it right here with this trigger name. So I'm asking to go get the collision profile name, which is this trigger, and set all the values to these things. So that sets our collision profile for the overlap. And then here we bind both of those new functions. So this is our class address and our function names. We could have called them anything we want. We could have said on trigger radius overlap begin. Whatever you name these functions just have to match whatever these are. And that's why these signatures have to be consistent, because this bind, this add dynamic, requires that those signatures match what it thinks it's going to, it's a on component begin or end. All right, so those are all kind of happening in our constructor. This is the overridden function for the post initialization of the properties. And we're simply saying set our sphere radius to whatever the sphere radius value is, which was, if you remember, we exposed the sphere radius to the blueprint class, and we exposed the show range checking game for debug in the blueprint class. So we're simply taking those blueprint variables and we're setting the corresponding values in our trigger radius. The begin play, first we call our super. This will likely never happen because of the net load on client statement, but it's just kind of another safety latch. It doesn't really cost us anything to do a double check that we didn't somehow end up on a client. So you really don't need that, but I stick it in anyway. And then we have to set the starting latch scenario. So what we're latching is we're latching the disable, but not the enable. So the way we start the game says, okay, the spawner is set up so that it can enable. There's no point in being set up to disable because nothing is already spawned. So we just set those initial values here. Then we set our timer. So we set our timer with the check for player nearby handle. We give it the function that it's going to call and the frequency it's going to call. This is the variable that has 120 seconds in it, and we tell it to loop. So this says, okay, set a timer. This is the handle that gets filled in. This is the function it's going to call, and then this is the frequency and looping of that. And then we immediately pause it because there's no point in having it ticking all the time. We simply set it up and pause it. We are, in this block, we're looping through the array, and we're just seeding the last transformation and whether or not the AI is alive. So these are just, it's a very simple seed. We're gonna do something more complicated later, but for now it's just populating those values. And then we're saving right here, we're saving the number of pawns that were in the array into this variable, so that when we kill things, we'll decrease this and we'll understand when we're at 0. And then we have one last thing to do on begin play is there's an edge case where the player might be inside the sphere radius to begin with, which means they're never going to trigger the on overlap because they're already in the sphere and they wouldn't see any AI. So what we're doing is on startup, we're simply checking, are there any actors that are of a Lyra character? And if I found any of them, so it's not empty, then go ahead and enable the pawns. And that's just for startup purposes in case a player is within the sphere to begin with. the on overlap begin, which gets called when the player crosses the threshold of the sphere component. We're simply logging that for debugging purposes. And we're checking if the other actor was a Lyra character, because other things can overlap with the sphere, like a bullet or other actors in the game or other AIs. We don't want that to trigger it. What we basically are checking here is that the actor that's triggering the overlap is in fact a Lyra character, which should be a player. Now we can do other checks there, and your game logic might require different things, but we're basically saying, okay, is this a player? If it is a player, then we're going to enable pawns, right? And then that's basically calls right here. And then let's take a look at enable pawns. Enable pawns first checks whether or not it needs to. If it's latched, it just returns. The scenario there is that the AIs are already spawned. You don't want to spawn a duplicate just because a second player crosses over the threshold, right? So the first player that crosses over the threshold enables the AIs, but if a second player crosses over, you don't want to double up the AIs. So this latch prevents that from happening. We then just, again, log for debugging purposes, and we're going to loop through the array. Now, one thing to know is that while you could do a for each, unfortunately, structs don't work well with the for each, or at least to my knowledge, they don't work with a for each. So if I did this and said it is a F AI, I don't even remember what it was. Hold on. If I tried to do it this way, which is perfectly valid for many variables, you'll get a compile error on the struct. So instead of doing a for each, we're using the counter version of that, where we just count up each index of this array and then start checking each one. So we're only going to process if the index of the array is alive and it does not have a pointer already. Now, it shouldn't have a pointer, but occasionally it might, so we want to double check that. So we're basically checking, is the AI alive, and we don't have a valid pointer, then we're going to spawn it. So this is the basic spawn logic in C++. It's the same as the spawn node we looked at in the last video in Blueprint. You set up your spawn parameters here, and the only one I'm changing from default is to adjust if possible but always spawn. And then we will we basically do get world spawn actor, and this is the type of actor we're spawning. This is the class we're spawning. This is where we want it spawned into the world, and the rest of the parameters come from the spawn info. The result of that will be an object reference pointer, which we will store in base pawn ref. So this spawns the character into the world. We store it here, and then we simply check if it's valid, then we were successful. So we just write that out that we were successful. Down here are just two error conditions. So if it failed this check, it was either it was not alive or it had a valid pointer. So these are just two error messages being logged if we fail this check. And so that for loop runs for as many entries as we have in the array for the AI pawns to spawn. And now we unpause that timer. because as soon as we're enabled, as soon as we have pawns in the world, we want to be seeing if we can recycle them. And then we take off the latch for disabling. So now that pawns are in the world, they are valid to be disabled. So that's a little, the latching might be a little confusing for folks. When we come into the enable, we first check if we were latched. If we were, we exit, we do nothing. But if we were false, we would pass that and we would latch it on. We would turn it on so that no more. We get through this one time only. But now we're able to disable, and we will stay like that until we disable. So right here, those lines are all about spawning the AI into the world, and then these ones are for spawning or disabling or despawning them. So on overlap end, when the player leaves the sphere, then we do the same check. We said, was that other actor a player? If it was a player, then we do this check because there might have been multiple players in that circle, and just because one left, we don't want to despawn the rest of the AI until everybody has left. So this check says, okay, check if there's anyone else in that area, and if not, and do whatever you need to do appropriately. So that's here. That says, okay, get any actors of Lyra character inside the trigger radius and populate this array, found actors. So it says, take the area of the radius, look for Lyra characters. If you find any, put them in this array. And so if we come out of there and the array is empty, which means we didn't find anyone inside the area, then go ahead and disable the pawns. Which is very similar to the enable. We've latched it so that we only get in once. And at the bottom, you see that we now re-enable the latch for enabling them back again. So between those latches, we will pause the timer because we no longer need it because we're disabling them. We don't need to keep checking if we're going to disable them. And we loop through that same array. This time, we're double checking that our base pawn reference is valid. And if it's valid, we're going to save the last transformation. Now, this particular example, he's stationary, so he's not moving. But in the case of the moving AI, then we're going to save the last transformation. We're going to basically destroy. So we're setting their lifespan to 1/10 of a second, which is the equivalent of destroy. It just waits a frame or two to destroy it. And then we're going to release the pointer. So we're going to set this base reference to null. So this is our current disabling logic. This will get more complicated as we add more and more to the class. But I wanted to just get a basic setup running. And then the last function is this one here, which is the post edit change property that we overrode. And you call the super, you always kind of call the super. And then here you have an F name where you're getting the property name, right? So we're getting the property name. This gets called for every property that changes. And then we're saying, okay, what is its name? If its name was spawn radius, or if its name was show range check in game for debug. So if it's either of these two variables, you're going to perform this code. If it's any other property, it just skips over this. So if we change the spawn radius, we're going to set the trigger radius to the spawn radius, the new one. And if we change this flag, we're going to change whether or not the trigger radius is hidden in game. And so that's all the code. Did make a few line changes, so let's go ahead and run it. Okay, so then editor, we did this in the last video. Okay, so all I did was create this idle NPC for now, which is basically a blueprint class. It's coming up on the screen. it's AI pawn. So basically, all it is the AI pawn class, which we haven't coded anything into yet, with nothing in it except the static mesh, and that static mesh has a simple character in it. So that's all it is. It just gives us something to spawn into the world. And then the spawner is basically a data only. So there's no code in the spawner, the Blueprint AI spawner. And what you'll notice right away is all of the other areas have been hidden. So the only thing you see are the parameters that we chose to show, right? And that's because of this section right here. So we hid all of these other ones, which is what makes our setup look so clean and simple and easy for a designer to deal with. So we have our spawn radius, whether or not we want it to be debugged. Note our AI to spawn, which is our array. We're only exposing these two, even though there are more, right? Even though there are more variables, only these two show up, which are here and here, and then our frequency and then our respawn variables. So these are the variables that we've defined. Then in our outliner, okay, so our outliner has, I don't know if you can see that on screen. Let me make this 500. See if you can see that. So you can see the sphere is 500. Make it 1,000. Got bigger. 1,500. Bigger. Okay. So the spawn trigger is this plane here. When the character passes through this plane, we will spawn our NPC into view. Now, you typically set this much bigger so that you don't see a character popping in and popping out. But for our purposes, we're going to just use it on screen for visualization. And then I have in this array one entry for the idle NPC, and stationary doesn't do anything yet, but just because stationary is just standing there, it's exactly what it's doing. But you see the enums here in the drop down. So those are our enums. And let's go ahead and run it. Okay, so you can see the radius over here, and you can see there's nobody in the middle. But as soon as I cross this line, he spawns in. As soon as I leave, he spawns out. So if I go in, it triggers the spawn. If I leave, it despawns. So let's do a couple more. So this is kind of a little weird, but is there a duplicate in there? I can't remember how to duplicate. Copy and paste. Okay, and drag the second one over here. So you can kind of see I've got two spheres, and I'm going to keep them so that they're overlapped. So I've got one over here that ends about these logs. I've got one that kind of starts at this table and goes this way. Now, imagine yourself on a much bigger world and that these circles are much bigger. This is what allows you to move through a level and the NPCs spawn or despawn as you are moving through that level. So with the 2 spawners in, we should approach the first one from the side. And he spawns in. Then we're going to get into the second one, and he spawns in. But this guy's still here because we haven't left his circle yet. Then we're going to get out of his circle, and he's gone. So now am I in his circle? I am in his circle. No, there, he despawned. That was the 2-minute cycle time because he was still present, but there was nobody in his circle. Now he spawns in. Second guy spawns in. Cross that line. He despawns. Cross this line. And he despawns. So you can see the spawner in action. And then what you would do in proper gameplay is we wouldn't have the show range check in game. So I'm going to turn that off. And we'll do it for this one too. I'm going to leave them exactly where they were. And you see me spawning into his circle, so he's there because I spawned inside. We're going to move over here. He's going to disappear. Note there's no circle around anymore, but it's functioning exactly the way we want it to function. All right, so that's the basics of the spawner. That should give you the kind of empty shell to start working with, and then we'll keep adding to that through the rest of the videos. Thanks for watching.